Okay, so the broadcast is started. This is the second number theory session. Last time we stopped at divisors. So today we pick up with divisors. And I'm going to motivate the notion of divisors by looking at a couple examples. So hopefully you guys can see my screen. And so the first example I want to do is the following. So the question says, show that 12 is a divisor of each of the following. So we have 12, and then we have the following numbers. We have 1, 2, 3, 4, 6, and 12 itself. So 1, 2, 3, 4, 6, and then 12 itself. And so the question is, we need to understand what it means for a number to be a divisor of a different number. And for that, let's take a look at the following. Let's try to divide our number 12 by each one of these numbers. So we know that if we divide 12 by 1, we get 12. We know if we divide 12 by 2, well, that's a weird looking 2, by 2, we get 6. And if we divide 12 by 3, we get 4. And by 4, of course, we get 3. And by 6, we get 2. And by 12, we get 1. Now, the point is that when I divide 12 by any of these numbers, the result is an integer. This is an integer, this is an integer, this is an integer, this is an integer. 1 is certainly an integer, so is 2. So a number, let's call it n, will be a divisor of 12 if when I tried to divide 12 by that number, the result here is an integer. Okay? So for example, if I try to divide 12 by 5, I know that there is no integer that I can multiply by 5 and get 12. This result is not, so whatever this is, it is not, let's write it this way, it is not an integer. And so 5, so we can say 5 is not a divisor of 12. Okay? So again, real quick, what it means for a number to be divisor of another number, it means that if I divide this 12 by that number, I get an integer. So in that case, n is called a divisor of 12. So that's the notion of a divisor. Now, a related notion is the notion of a multiple. So this was our divisor. Now, a related notion is the notion of a multiple. And we know what a multiple is, of course. If we look at, for example, 2 times 5, which is 10, of course, it is a multiple of 5, right? It's 2 5s. If we look at 3 5s, that is also a multiple of 5. Negative 4 5s is also a multiple of 5. Now, let's look at our divisor again. What do we see? Let's say we have 12 divided by 4, and we know that is 3, and we established that 4 will be a divisor of 12, right? 4 is a divisor of 12. Now let's multiply both sides of this equation by this 4, and we get 12 equals 3 times 4. And what does this tell me? This tells me that 12 is a multiple of 4, right? How many? 3 4s. 3 4s. So 12 is a multiple of 4. But 4 is a divisor of 12. So this suggests a relationship between the notion of a divisor and a multiple. So let's look at a different example to try to understand this better. So let's say we look at 15 divided by 3, and we know that equals 5, which is an integer. So as we learned, that this implies that 3 is a divisor of 15. At the same time, if I were to multiply both sides of this equation by 3, I would get 15 equals 3 times 5, which means the number 15 is a multiple of 5, right? I need 3 5s to get 15. So this is a multiple of 5. And it's a multiple of 3 as well. How many 3s do I need? I need 5 3s. So let me, instead of this 5, let me focus on the 3. I need 5 3s to get 15. So look at this relationship. 3 is a divisor of 15, which means 15 is a multiple of 3. And the other way around, if 15 is a multiple of 3, then 3 is a divisor of 15. I hope you can see this relationship, right? If 15 is a multiple of 3, that means 3 times some number, some integer, gives me 15. That means that if I were to take that 15 and divide by 3, I would get that integer that when multiplied by 3 gave me this 15. So we have this relationship between the notions of divisor and the notion of a multiple. And so we can formalize it by writing the following. So we're going to try and formalize this. So first of all, when d is not equal to 0, and we'll see what d is in a second, the following statements all mean the same thing. The first statement is n is a multiple of d. N is a multiple of d. So some number, some integer times d gives me n. N is a multiple of d. This statement is the same as the statement n is divisible by d. N is divisible by d. And I'll write examples here on the right so we can keep it so for motivation. So n is a multiple of d. What does that mean? Well, let's say, so as an example, let's just say d is 3. So I'm going to write the following. I'm going to write 3 times 5 equals 15. So this 15 will serve as my n, and d is, of course, my 3. Notice that 15 is a multiple of 3. I need 5 3s to get to 15. That's the statement A. Statement B says n is divisible by d, which was 3, right? So if 3 times 5 is 15, then I can divide both sides by this 3 to get an integer, right? So 15 divided by 3 gives me my 5, which means that 15, the n, is divisible by 3, which is the d, because I get an integer as a result. The third statement says d is a divisor of n. D is a divisor of n. Well, this is very closely related to statement B, right? They're almost they even sound the same. So if n is divisible by d, that means d is a divisor of n, right? N was 15, d is 3. Saying 3 is a divisor of 15 means that if I take 15 and divide by that 3, I get an integer, which means that 3 is a divisor of 15. D is a divisor of n. And the last statement is d divides n. Divides n. In other words, you take n, you divide it by d, you get an integer. So same as here. These 4 statements mean the same thing. And the reason I say when d doesn't equal 0 is because we obviously cannot divide by 0, so we need that statement there. Now, a special case of all this is the following. We know that for any integer n, so if n is an integer, we can write it as n times 1. So what does this mean? This means that n is a divisor of itself, is a divisor of itself. Why is this true? Because if I were to divide both sides by n, what would I get? If I were to divide both sides by n, what would I get? I would be left with this 1, right? Which is an integer. If I take a number, divide by a number, and the result is an integer, we know that that number is a divisor of that numerator. So this n here is a divisor of this numerator, but they're the same, which means n is a divisor of itself. Okay? Now, this statement here has one exception. I hope you can see what the exception is. The exception is when n is 0. And again, the reason is that we cannot divide by 0, so we just cannot make this statement whatsoever. And in number theory, 0 usually has some special properties associated with it, just because the notion of a divisor is a bit iffy here. Like for example, in here we cannot divide by 0, so we cannot say 0 is a divisor of itself. But for any other integer, yes, any other integer is a divisor of itself. Now, we make a definition of a proper divisor. So what does it mean for a divisor to be proper? Proper divisor. Let me do a quick check to make sure no one has said anything here. Let's make sure. Yes, good. All right. So what does it mean for a divisor to be proper? So a proper divisor of n, a proper divisor of some integer n is a positive divisor, of n that is not n itself. So remember, we said for any non-zero number, that number is a divisor of itself, right? We just showed that n over n equals 1. So that the number itself we don't take into consideration. Every other positive number is a proper divisor. So let's look at a couple examples. Let's say I take n to be 6. So now you start thinking to yourself, which numbers, positive integers, are divisors of 6? Well, 1 certainly is, right? Because 6 divided by 1 is 6. 1 is a divisor of 6. 2 is a divisor of 6 because 6 over 2 is 3. 3 is a divisor of 6. 6 over 3 is 2. Now, 6 is a divisor of 6 because 6 over 6 is 1. But only 1, 2, and 3 are the proper divisors. Remember, the proper divisors are the divisors that are not the number itself. Okay? So 1, 2, and 3 are my proper divisors. So that's the notion of a proper divisor. Now, let's take a look at the following example. Let's look at 0 over n. Now we know, and let's suppose n is not 0, because we know we cannot divide by 0. Now we know that 0 divided by any integer is going to give me 0, right? This here, this expression here, is going to give me 0. So what kind of number is 0? This is an integer. Now what did we say? We said when we take an integer and divide it by another integer, if the result is an integer, the denominator here is a divisor of the numerator. Now we took 0, we divided by n, and we got 0, which is an integer. So what does this tell me about n? This tells me that n is a divisor of 0. Now n is arbitrary. N is absolutely any integer that is not 0. This means what? This means every non-zero integer is a divisor of 0. Okay? Every non-zero integer is a divisor of 0 because when I take 0 and divide by that integer, I get an integer. Now remember that the statement is equivalent to saying 0 is a multiple of every integer. Right? When did we say a number is a multiple of another number? Well, that's the case when we take this integer, multiply by some other integer, and we get 0. Well, you give me any integer you want, let's say 32, I need to get 0 by multiplying this 32 by some other integer. Well, I know what that integer should be. It should be 0, right? Give me something else, negative 12. Well, again, I can multiply by 0 and get 0. This tells me that 0 is a multiple of negative 12. Okay, so remember, while 0 is 0 a multiple of 0? Sure, 0 times 0 is 0, right? So while 0 is a multiple of every integer, only every non-zero integer is a divisor of 0, because again, we cannot divide by 0. So we have to make this distinction when we're talking about divisors, because you cannot have 0 in the denominator. I hope that makes sense. If it doesn't, make sure to ask in the Discord channel, and I'll try to explain this further. All right, so let's see here. Let's go. Let's take a look at a different. Let's take a look at the different problem. So all the problems that we're going to look at are motivating these notions of divisors and multiples. And so this one says find all natural numbers that are divisors of 6. So we already did that, right? Now, what are natural numbers? Natural numbers are numbers we use for counting. And some people start natural numbers from 0. We won't. We'll start it from 1. So natural numbers for us will be the set 1, 2, 3, 4, etc. So the positive integers. Okay. Now we want all the natural numbers that are divisors of 6. Divisors of 6. Well, we know what those are, right? That's 1, that's 2, that's 3, and that's 6 itself. Now, just to sort of enforce the terminology we looked at, which ones are the proper divisors? Well, the proper divisors are only 1, 2, and 3. 6 itself is not a proper divisor. Find all natural numbers that are divisors of 18. Well, let's take a look at the divisors of 18. Well, we know that's 1. 2 is a divisor of 18 because 9 times 2 is 18. 3 is a divisor. 6 times 3 is 18. 6 itself is 6 is a divisor. Again, 3 times 6 is 18. 9 is a divisor, and 18 itself is a divisor. Which ones are the proper ones? These first 5. Now we see something interesting. We see that the first 4 divisors are exactly the same as for 6. Right? Why is that? Well, we can write 18. Let's think about this. We can write 18 as 6 times 3, right? So if 18 is 6 times 3, then whatever number is a divisor of 6, if a number divides 6, then it'll divide 18 as well, right? So let's take a look. For example, 18 is 6 times 3. 6 times 3. Now, let's take a look at this divisor of 18, 2, for example. We know that 2 is 6 times 2 is a divisor of 6, right? Because 2 times 3 is 6. So I can write 6 as 2 times 3, and I have this extra 3 here. Look at this number. This is the same 18 as I had before, but now I can clearly see that 2 is a divisor. This number can be divided by 2, right? The result will be 9, of course. What other number is a divisor of 6? Well, 3 here, right? So let me write this 6, or 6 itself, or 1. So, so we can see here, we can sort of, we haven't proven this yet. This is not formal, but we can sort of get an intuition that any number that's going to be a divisor of 6 is also going to be a divisor of 18, just because 18 is a multiple of 6. It's 3 times 6. So the question is, explain how we could know that all the answers from part A, which is here, this is our part A, the divisors of 6, must also be answers to B here. This is B. So this is the question, right? Explain how we could know that all the divisors of 6 will also be the divisors of 18. Well, let's go back again to the definition of a divisor. What does it mean for a number to be a divisor of another number? Well, we said that m is a divisor of n if n divided by m is an integer. So this meant that m is a divisor of n. Now what do I want to do? I want to make sure that the divisors of 6, all the divisors of 6, are also divisors of 18. Now, these are divisors of 6. What does that mean? That means that if I take 6 and I try to divide by any of these numbers, let's call them m here, any of these numbers, I get an integer. Again, if I take 6 and I try to divide by any of these numbers, I get an integer. Fine. M is like a placeholder representing any one of these numbers here. Now let's replace 6 with 18. And let's think about what would happen if I divided this 18 by the same m, which represents any of these divisors of 6. And to see this clearly, let's rewrite 18 as 6 times 3. What do we know? We know that m is a divisor of 6. What does that mean? That means if I take 6 and divide by m, I get an integer. So what does this give me? This gives me an integer times this 3. Well, an integer times 3 is again an integer, right? So 18 divided by this m again is a number from this set here, any one of these numbers, is an integer. What does that mean? That by definition means that m, so this implies that m is a divisor of 18. Okay? Why is that again? Because 18 is a multiple of this 6. It's 3 times 6. Now, should give you an intuition. You can think about any other multiple of 6. How about 24? How about 24? So if I look at 24, well, you say, let's rewrite 24 as 6 times 4, which again, I can even simplify further. I could write it as 6 over m times 4. This is simple multiplication of fraction by an integer. We know this works. Now, m is a divisor of 6. What does that mean? That means this ratio here is an integer. And an integer times 4 is definitely an integer. Now, I took 24, I divided it by m and got an integer. What does this mean? This, by definition, means that m is a divisor of 24. Okay? So, again, if this is still unclear to you, if you're not quite sure, just pick any multiple of 6. 18, 24, 36. You pick a multiple and try to prove this for yourself. Try to go through these steps yourselves and gain an intuition for this. It's a very useful exercise. Okay. Now the book goes on to mention something that is that might be thought of as obvious, but nevertheless I'll mention it. For example, if we're hunting for the divisors of 36, right? We know that the divisor of 36 cannot be bigger than 36. Why is that? Because if I take a number that is bigger than 36, say 54, and I try to divide by 36, like so, this is going to be a number, some number here. Now, if 54 is a divisor of 36, actually, let's do this. Let's do this in the other direction. If 54 is a divisor of 36, then what does that mean? By definition, that means if I take 36 and divide by 54, I get an integer, right? This is what it means for 54 to be a divisor. Well, now if I move the 54 to the right by multiplying both sides by 54, we get 54 times an integer equals 36. Well, that just cannot happen. If your integer is positive, 1, 2, 3, 4, 5, you get numbers bigger or equal to 54, which cannot equal to 36. If your integers are negative, -1, -2, -3, then you get the same things except negative, -54, -108, etc. None of them can equal the positive number 36. If your integer is 0, the result is 0, which again is not 36. So this cannot happen. So you know that your divisors are going to be smaller than 36. Okay, the positive divisors are between 1 and 36. This intuitively makes sense. We know this intuitively, but this can be thought of as an argument as to why that has to be true. Okay? All right. Now, moving forward. Let's look at the following statements. So the statements are the following statements all mean the same thing. More importantly, understanding them will help us solve many number theory problems. Okay, so here are some statements that are supposed to mean the same thing. Let's see what the statements are. First statement is if A is a divisor of B, so if A is a divisor of B, and B is a divisor of C, and B is a divisor of C, then A is a divisor of C. So let's try and make up some examples here. So we want two numbers, A and B, such that A is a divisor of B. Well, okay, 2 and 6. 2 is definitely a divisor of 6 because 6 divided by 2 is 3, right? Now we also want a third number, C, such that B is its divisor. Well, how about 12? 6 is definitely a divisor of 12 because 6 times 2 is 12, right? So this statement here says that if 2 is a divisor of 6, and 6, if 2 is a divisor of 6, and 6 is a divisor of 12, then 2 is a divisor of 12. So let's try to understand why this is. What does it mean for a number to be a divisor of another number? Well, this means that 6 divided by 2 was an integer, right? Now 6 is a divisor of 12. That means 12 divided by 6 is an integer. Okay? Now, so now I need to show that 12 divided by 2 is an integer. How am I going to show this? Well, I can say that 12 divided by 2 is the same as 6 divided. So 6 times some integer, right? Because that's what 12 divided by 12. What is 12 here? So let's multiply both sides by 6. We get 12 equals 6 times some integer. Now I take this 12 here and I replace it with the 6 times an integer, right? And I can, of course, rewrite this as 6 over 2 times whatever this integer may be. And I know that 2 was a divisor of 6. So this expression, 6 over 2, was an integer. So what do I get? I get an integer right here times this integer. And an integer times an integer is of course, an integer, which means 12 over 2 was an integer. So 2 is a divisor of 12. Now, this is an example. This is not a proof. So let's try to formalize this and turn this into a general case. So if A is a divisor of B, what does that mean? That means B divided by A is some number, some integer. This is an integer here. Then I know that this other number G, let's say, or C, excuse me, we call it C. So B is a divisor of C, which means C divided by B is also some integer. Let's call this dn, actually. So what is my goal? My goal is to show that C over A is also an integer. Then A would be a divisor of C. How am I going to do this? Well, we'll do the same thing as we did in this example. First, we'll take this expression, we'll multiply both sides by B, and we'll get that C equals M times b. Now I take this expression and put it here for c, and I get m times b over a. Now I can rewrite this as m multiplied by b over a. Why am I doing this? Because I know that b over a is an integer. I was told that a is a divisor of b. So I can replace this b over a with this n, and I get m times n, both of which are integers. So the result is an integer, implying that a is a divisor of c. And we're done. Okay, a is a divisor of c. Now, an equivalent statement is saying if b is divisible by a, so if I have that, let's pick the pencil here, if I have that b is divisible by a, and c is divisible by b, and this third number c is divisible by b, you can guess what's coming. Then c is divisible by a. Why is this the same thing as before? Well, if b is divisible by a, that literally means that b divided by a is an integer, just like before. C is divisible by b, that literally means c divided by b is an integer. Why would this imply that c is divisible by a? Because now c over a can be rewritten, and we do the same thing here, right? We move the b over, we get n times b, and we put it in place of c. We get n times b over a, but notice this, b over a is an integer. So I separate this, n times b over a. B over a was my integer m, and I get integer times an integer, which is an integer, and I'm done. So the statement is the same thing. So these two statements, first one saying if b is divisible by a and c is divisible by b, then c is divisible by a, is the same as saying if a is a divisor of b and b is a divisor of c, then a is a divisor of c. This makes sense, right? If a is a divisor of c, if a is a divisor of b, b is divisible by a. If b is a divisor of c, c is divisible by b. If a is a divisor of c, c is divisible by a. So these two statements are equivalent. And the third statement, which is equivalent to both of those, is that if b is a multiple of a, so if b is a multiple of a, and let me just write what this means. B is a multiple of a. That means that a times some integer is equal to b, right? A times some integer is equal to b. Well, look, how about this? How about taking this equation and dividing both sides by a? What do we get? We get exactly the statement before, that a is a divisor of b. Why is that? Because when divided, I get an integer. It's the exact same statement as before. Now, continuation of the statement says, and c is a multiple of b. Well, what does that mean? That means b times some other integer equals c. Well, again, let's take this equation and divide both sides by b, and we get that m equals c divided by b. And right there, right here, I have the statement that b is a divisor of c. Why is that? Because when I take c and divide by b, I get an integer. So this statement here is the same as saying b is a divisor of c, which is exactly what I have what I have here. B is where is it? Right here. B is a divisor of c. So these statements are equivalent, and it's just kind of a play on words, really. The notion of being a divisor and being divisible by. So hopefully with some practice you get used to this. All right. Now let's just for practice, let's do one exercise here, and then we'll end it. So this was going to be a simple exercise, but this is just a mechanical exercise. So we want to list all the positive divisors of each of these numbers. Let's start with 4. What are the positive divisors of 4? Well, 1, 2, and 4 itself. What are the proper divisors? 1 and 2, right? So what can we say about these? These are divisors of 4, which means that 4 is divisible by them, which means that 4 is a multiple of them. Okay, notice this all these statements mean the same thing. They're just phrased in different ways, but they convey the same information. Second number, 7. What are the positive divisors of 7? Well, 1 divides 7 because 7 divided by 1 is 7, and 7 itself. And I'll say that I'll keep repeating these phrases to drive the point home. These are the positive divisors of 7. 1 is the only proper divisor of 7. 7 is a multiple of both 1 and 7. Third number, 8. What are the positive divisors here? 1, 2, 4, and 8 itself. 1, 2, and 4 are the proper divisors of 8. 8 is divisible by these 4 numbers. 8 is a multiple of these 4 numbers. Okay, 3 more, and the rest of them I'll take a picture and post it on Discord so you guys can practice this. And remember, the goal of this exercise is not just to write out these numbers. Anyone can do that. The goal is to repeat these phrases to yourself so you can get used to their equivalents, that they mean the same thing. So the next number is 10. 10's positive divisors are 1, 2, 5, and 10 itself. 1, 2, and 5 are its proper divisors. 10 is divisible by any of these numbers. 10 is a multiple of any of these numbers. 5. The number 13. The proper divisors of 13, excuse me, not the proper, the positive divisors are 1 and 13 itself. 1 is the only proper divisor. 13 is divisible by any of these numbers, and 13 is a multiple of these two numbers. And finally, the number 14, its positive divisors are 1, 2, and 7. 1 and 2 are its proper divisors. 14 is divisible by these 3 numbers. 14 is a multiple of these 3 numbers. Okay, so hopefully you see, hopefully this gives you some practice. I will post some more questions on the Discord channel so you guys can practice. But I'll actually write the questions here as well. So think about, do the same exercise, but for the number 15, 16, 19, 20, 21, 24. 21, 24. So do the same exercise. Write out the positive divisors here. And then tell yourself which ones are the proper ones, and make sure you understand the equivalence between the numbers being multiples of some numbers being their divisors, these guys being divisible by some numbers. Hopefully this will give you enough practice with that. All right. So with this, I'm going to end the session for today. This is going to be a short one. So again, we're just covering the very fundamentals right now, but in a couple days' time, we'll get into the next chapter, which is prime numbers. And once we cover prime numbers, then the beauty of number theory begins. Prime numbers are the basic fundamental building blocks of the subject. So thank you, guys. Post your questions on the server. Myself and others will help you out. Have a great evening, and I will see you next time.